So this is our last lesson in our unit on chemical reactions. We're going to look at double displacement reactions today. So you should have already learned a little bit about double displacement back in grade 10. But today we're going to learn more about why it happens, when it happens, how you can predict when it will happen. So there are a couple of data tables that are posted online in the lesson folder. You'll need those shortly. So if you don't have those handy, you'll want to pause the video, grab them or have them up on your screen. We're going to take a look at them on the screen as well in this lesson, but having them handy to practice with will help you understand a little bit more about how to use them. So what happens in double displacement reactions? So here you've got two cations, and cations are positively charged ions, and I usually remember cations means positively charged because in the word cation there's a T, it looks like a plus sign. So these two ions, they're found in two compounds, and they're going to exchange places to form two new compounds. Or another way of thinking about it is you're doing a partner swap. You've got two people paired up, and one partner is going to swap with another. So here if we look at a general equation, that would mean partner A and partner B are going to switch and have new anions, the negatively charged ions, which are X and Y. So when does this happen? It doesn't happen all the time, but what you're looking for is some kind of new product to be produced. You have to have a new product being formed for the reaction to take place. If you don't get a new product, that just means no reaction. So similar to single displacement reactions, no reaction can apply here as well. So we'll take a look at that in a minute. What kind of things are new products? There are a couple of things we're going to look at. One is the formation of a precipitate. So if you remember that word from grade 10, this means the formation of a solid. The second option, what if you make a new gas? That's also possible, and we'll look at some specific examples of some gases that could get produced. And then another example will produce water. But if we think about, well, what's water? Water is a liquid. So really here what we're saying is a new product has to be a solid, a gas, or a liquid being formed. And that will mean we have a double displacement reaction happening. When we're dealing with precipitates and solutions, there's a couple of terms we need to be familiar with. And we'll look at those next when we talk about precipitates. So, first case, what happens when two aqueous solutions are mixed together? If the reaction is going to take place, you get a solid being formed. And this is where we're going to take a look at that solubility chart. So again, if you don't have that out yet, you're going to want to pull it out to have it handy. We're going to flip to it in a moment. So let's take a look just at the precipitate. So we're going to take a look at this equation here. So we've got barium chloride. It's reacting with potassium sulfate. Both of these are aqueous to start, and you need to have both compounds aqueous for them to react. When we look at our product, we have barium sulfate and potassium chloride. But the key thing here, when we look, the state here for barium sulfate is that it's a solid. Our other compound over here, potassium chloride, is aqueous. That's okay, as long as one of our products is a solid, a liquid, or a gas, then we know the reaction takes place. You could also have two solids being produced. Both products could be precipitates, but that's not as common. So what does this mean? How do we figure that out? So here are those terms that we need to know before looking at the solubility chart. Soluble and insoluble. So when we look at the word soluble, it means that something is going to remain in solution when dissolved in water. Basically what this means is anything that's soluble should have aqueous written beside it. So all of those three things that I just highlighted, those are soluble compounds. They stay dissolved in water when they're in solution, or they're aqueous. You can even make a note in here, this means aqueous. But what does insoluble mean? That means it doesn't remain dissolved in solution. It has no solubility, and that means we get our precipitate form. Or here in this example, barium sulfate, that's our precipitate. So precipitate formation means solid. So now let's take a look. Thinking back to this example, we're going to flip over and look at a couple of solubility charts and how we use them. So pull those out if you haven't. We're going to go over here and take a look. So here's one solubility table, and we're going to look at our two products, so barium sulfate and potassium chloride. So let's look at barium sulfate first. Here's barium. All of the positive cations are at the top. And then vertically we have our anions, the negative ions. We're going to look for sulfate because we have BaSO4. And we're trying to figure out right where they meet. So if we look at where they meet on this chart, we get this letter I. But letter I, if we have a look down here, it means insoluble. And remember what we just said about that? That means it's going to form a precipitate or a solid. So that's how we can figure out when the two ions combine together, what is the state going to be. In this case, I means insoluble or precipitate. But if we look at the other example, our other product, it was potassium chloride. So let's do this in a different color here. Potassium and chlorine. Where they meet this time, we get the letter S. For this chart, letter S means soluble, and that means it's going to stay dissolved in solution or it's going to stay as aqueous. So this table here is really easy to use. You look for your two ions and you match up where they meet, and it tells you about some data down below. Now there's one other type of solubility here with a star on this chart, sparingly soluble. What does that mean? It means really small amounts of that compound can dissolve. But besides that, most of the time it's insoluble. So for what we're going to do for our purposes at this level of chemistry, if you see sparingly insoluble, it probably means that it's just insoluble or will form a precipitate. You learn more about that in grade 12 chemistry, what happens with these guys here. There are some other data tables that have solubility charts. There's one in your textbook that looks similar to this one. And the way that it works is the same, but it's just a little more generic. Up here you've got anion, that's the negative ion, and then it's showing cations, those are the positive ions. And what happens when you combine them together? And then you get an indication of solubility over here. Is it soluble, which means dissolves, aqueous? This one calls insoluble or slightly soluble. They call it low solubility, so that would mean precipitate is formed. So if we look, for example, for our barium sulfate, we said it was going to be solid. Here's that sulfate ion. Here's the barium ion, and it tells us low solubility, and we know that means a solid in our case. So either table's great. You'll get both. Some information's found easier on one, and some information is found easier on the other. So if one table doesn't have the information you need, have a look at the other. It'll definitely be there. So that's a little bit about what happens when we take a look at a solid forming or precipitate. That's our first case. Now what we're going to do is take a look at what happens when you produce a gas. And we'll look at some specific examples and some patterns you should be familiar with. So let's take a look at a couple. Just adjust that. There we go. So second case for double displacement reaction, what if you produce a gas? So down here we have two examples. Let's look at one at a time. So here first we have sodium sulfide. We're just going to call this any sulfide compound. When that sulfide reacts with an acid, in this particular case it's hydrochloric acid, what we're going to see is you're going to get a compound forming. And that will depend on your acid and your sulfide. We'll come back to that in a minute. But if a sulfide reacts with a gas, you always get, sorry, I take that back. If a sulfide always reacts with an acid, you always get one type of gas, and the gas specifically formed here is hydrogen sulfide gas. So anytime you have a sulfide reacting with an acid, you're going to get hydrogen sulfide gas and a compound. How do you know what the compound is? Well, it'll always be the positive ion with the sulfide, in this example sodium, and it's over here, and it'll always be the negative ion with the acid, in this case chlorine, and it comes in here. So our compound would be sodium chloride, and it states aqueous. So if you needed the state here, you would go and use that solubility table, just like we did for the previous example with precipitate formation. And then of course you have to balance the equation. So that's one specific example you can be familiar with. Another one here is similar, but it's with a carbonate. A compound with a carbonate. So there's that carbonate ion. We're reacting it again with an acid. Same acid in the previous example, but it could be any acid. We're going to do the same sort of thing. Make a compound. But now we're going to have two other products that decompose and form. One of them is always going to be water, H2O. And here the other gas is carbon dioxide. And again, the same pattern happens when you look at, well, what's the compound? It's always the positive ion with the carbonate and the negative ion from the acid. And then the other two will always be water and carbon dioxide. So there are others, but most of the ones involving double displacement are pretty specific. So just being familiar with a couple of specific examples and their patterns, those are the ones that I would focus on for right now. Now we're on to our last example of double displacement, and this one involves neutralization. So if you remember, neutralization comes in when we have acids and bases. And in an acid-base reaction, what do you get? You get water being formed. So here, what we're going to do, our acid, we're just going to generically call it HA. H for the hydrogen ion and A for the negative ion. Acids always have H. Our base, we're going to call it BOH. B for a positive ion, and the hydroxide ion you see being involved with bases. So let's take a look at the pattern. And this is what you should have learned last year. Acid plus a base gives you salt and gives you water. So here what's happening, we've got a couple of ions that switch places. And you get your salt forming and your water. Now, the salt here, if you want to find out what the state is, you're going to use that solubility table. So finding out the salt, it's an ionic compound, but is it soluble or not? That can vary, so check your solubility table. And the water is always HOH, or you can just write it as H2O, it doesn't matter. But HOH sometimes helps you see the pattern a little bit more about why it's double displacement. So now what we're going to do is try out a couple of examples together to see if you've got the idea. So let's take a look at the two examples. So there's a couple here. Sorry, I take that back. There's three. So what you want to do is try and predict what the products will be if you think it's possible. And then if it's possible, write out the proper equations and then balance them. So at this point in the lesson, if you want to try them first, I would pause the video, give yourself some time to try the three examples, and then turn the video back on, unpause it, and we can check the examples together. So go ahead and pause. All right, welcome back. Hopefully you tried some of those examples yourself. So now what we're going to do is look at what our products are going to be and see if there's a reaction taking place. So double displacement, remember, means the first two are going to switch places. So that means silver is going to go with chlorine and make silver chloride. Both of these have a charge of 1 and 1. So when you do the crisscross, you get 1 and 1. And our other product here is going to be calcium with nitrate. But calcium, remember, has a charge of 2 and nitrate has a charge of 1. So the 1 will come down here, but the 2 goes for the entire nitrate. Then we need to look up the states, and we want to make sure at least one of these has to be a solid, a liquid, or a gas. So definitely no liquid here. Pretty sure these aren't gases, so we're going to go and look at our solubility table to figure it out. When you have a look at your solubility table, silver and chlorine, when you check it, it should show low solubility, or it should say insoluble. That means it's going to be your solid. Do the same thing for calcium and nitrate. When you check those two, you should find this one is soluble, so that means aqueous. You might notice a trend with nitrates. They're very soluble. So in your table, pretty much everything is soluble with nitrate. So now when we take a look, is the reaction happening? Definitely. This here is our new product. We have a precipitate. So since we have a new product, we know this reaction is possible, and now we want to make sure our reaction is balanced. So if you haven't balanced the equation yet, make sure that you go through and try balancing it now. So now when we go through and balance, we're going to put a 2 here, and we're going to go and make sure there's a 2 there. Then let's take a look at the next example. So for our next example, we've got sodium nitrate and potassium chloride. If we were to write out both products, we would get sodium chloride and we would get potassium nitrate. And checking their solubilities, they're both soluble. But now, if you take a look, both are aqueous. Here, since both are aqueous, this reaction doesn't happen. No reaction. So you don't even need to write out the products for these ones. You can just write no reaction, but if you find it easier to write out the products and then decide whether a reaction takes place, you can do that. Last example. Here, when we have a look, this is sulfuric acid and this is sodium hydroxide. So this is a case of double displacement, but it's specifically acids and bases. So when the two switch places, we get hydrogen and hydroxide. That's our water. Water is a liquid. And now we have sodium and sulfate. Sodium sulfate is Na2SO4. When we have a look at that, here is our new product, water. So new product, that's our water. We know this is happening, so then we need to go and balance the equation, which means you need a 2 here, and you need a 2 there. So there's your lesson on double displacement. So try out some of the practice problems in the lesson folder, and send me your questions.